Hi there. With this lesson, we begin our journey in the data structures section of the course. I've already created a project in Eclipse called Learning Data Structures, so you should go ahead and do the same. And let's first create a package called ADT, right? And that is the topic of this lesson. ADT stands for Abstract Data Types. An abstract data type is another one of those fancy terms that's used all over in computer science, especially when referring to data structures. But it's actually a very simple concept if you understand object-oriented programming. That's why we've already covered that in the previous section. So you should be well equipped to learn this topic now. We've been using data types throughout the course. A data type is simply just a set of values and operations you can run on those values. For example, the int data type, if you have a variable of type int, you can assign the variable a number and then run some operation on that number, such as add it with something else or subtract, divide, etc. That's a data type, and more specifically, an int is a primitive data type. And it's called primitive because it's predefined by the Java language as a reserved keyword. It's a basic building block of the language. And if you try to look for the primitive ints class, you won't be able to find it. It's a building block of the language. An abstract data type, on the other hand, is capable of handling more advanced functionality using data and running operations. Think of an abstract data type as a trustworthy object or utility capable of performing certain operations on data. And in Java, abstract data types are created using classes. You can create an instance of an ADT and store data in it or invoke operations to change the data. Now, doesn't this sound familiar with the animal class you created in the previous section, in the object-oriented section? You created an instance of that animal and assigned it some data and invoked methods on that object, such as run, fly, eat, sleep, or whatever it was. It's essentially the same thing because ADTs are backed by a class in Java, but it's referred to in computer science in more of a theoretical way. You should think of abstract data types as trustworthy containers capable of doing things with data. You can use them as sort of a tool by creating an instance of their class and invoking their methods without having to worry about the guts of how the thing works. In computer science, its representation, an ADT's representation, is meant to be hidden from the client that uses it. So let's create an abstract data type. I'll give you instructions, and you should be able to go ahead and create it on your own. So you can take this as an assignment. We'll create an ADT called counter, which will maintain numeric data and does exactly what it sounds like. It will be used to keep track of the current number that's being advanced. Right? It's a counter. And clients can use this ADT without worrying about the internal details of this class. So here's what you need to do. Create a class called counter. The constructor should accept a string to represent the name of the particular instance. And there should be 3 public methods that can be invoked on the object to carry out certain operations. And those are, the first method is going to be called increment. And it does exactly what it sounds like. It just advances to the next available number. It does not return a value. The next method is called getCurrentValue, and that should return an int. And the third method is called toString, and that should return a string representation of the current state of whatever the counter object is. And inside of this class, you're going to be using the int primitive data type to maintain the value of the counter. And when a client first instantiates an instance of counter, its initial value will be 0. And a client will be able to use this abstract data type to increment the current value, and the client can call getCurrentValue to get the number that it's currently at. So go ahead and try this out on your own, pause the video, and when you're done, you can resume to watch my version. Alright, hopefully you had a chance to create that counter. I'm going to do it right here. Go to New, click Class, and it will be called Counter, and we don't need the main method in here. So hit Finish. So this abstract data type is going to be a container of 2 values. One of them is going to be of type string, and that will just basically maintain the name of whatever we give this instance when we create an instance of this class. And the other one is going to be an integer value. We'll initialize it to 0, and in the constructor, it accepts a string argument, and whatever's passed into this will be assigned to this dot name. Okay? And now we need the increment method, which is going to be void. It does not return a value. Increment, and we'll just increment value by 1. The next method is going to be get current value. It's going to be returning an int, and all this guy is going to do is return the current value. And finally, we need the toString method, which is going to return string data. So toString, and basically this is going to return the string representation of the state of this object. So we're going to do return name, and I'll just add a colon with a space right there along with the value, whatever value is. All right, so this is our abstract data. And since we don't want people to be changing these values, our clients to be directly knowing what these attributes belong to this object, we can just make these private fields, just like that. And now we can create an instance of this guy. Let's first create a class, and I'll call it app class. This is going to contain the main method. And in here, I'll create an instance of our counter. I'll call it myCounter. And I'll give it a name. I'll say myCounter. Okay, and remember when we initialize this counter object, it will have the initial value of 0. Right? If you go back to the class definition, it starts with a value of 0. And now using this abstract data type, I could just call increment on it multiple times. Just like that. And let's print the value for whatever myCounter contains. We'll say get current value. Hit the play button and notice that we're at 4. It initialized at 0 from this line, and then it moved to 1, 2, 3, and 4. Okay? Now typically in computer science, the idea of an abstract data type, as I mentioned, is supposed to be hidden. The implementation details of it can be trusted, right? It's a trustworthy object. And an object has a public API. For example, if this counter, if in this class we had a private method here, and let's say it does something, all right, whatever is in here, it doesn't really matter, but if we try to do myCounter dot, notice that it has get current value, it has increment, but you won't see the new method that we created because that's not a public method. All of these other methods you see here are actually inherited by the counter class, if you remember from our chapter from inheritance. These methods every object has. But the ones pertaining directly to this counter abstract data type are these methods increment and get current value, as well as toString. So think of this as a container, sort of a black box. You can invoke methods on it. It contains data and does things with data. All right, that's what abstract data type is all about, and that's what a lot of the data structures are referred to as. They're referred to as abstract data types. They're containers for data and operations, and you can use them to do things in a computer program. For example, in the next lesson, we're going to look at something called the linked list data structure. And that is also available in Java. I can create an instance of linked list. All right, and I'll say my list is equal to new linked list. Just like that. And notice that it's not a class that I created. It's something that's provided by Java. So I can import linked list right here. If you hover your mouse here, it says import linked list. And I can use this as sort of a black box to do things, such as add things to the list and remove them. So I could have very well wrapped this counter class in sort of a compiled version of the program and imported that as a library here, just like we are doing a linked list. We're importing the linked list. I could have done the same with counter, but since we are the creators of it, it's available to us. We can actually go into the definition and change it. If you hover your mouse over here on linked list and you hit control and click on it, you can access the definition of this class. And we can trust that all of these methods will behave accordingly based on the public API. All of these methods add all. These are basically methods we can use. Clear, this is a public method. All public methods will be available for clients to use. Let me see if I can find a private one here. For example, this is a private method. This we cannot use. This is probably being used somewhere within this class. But we don't have to bother with these details. We just take this linked list object as sort of a black box. We can do things with it. It's an abstract data type. Most languages have these fundamental abstract data types already implemented within the language, including Java. And there's a number of those data structures, such as linked lists, stacks, queues. So understanding the internals of how they work actually will help you write better programs. So in the next lesson, we're going to create our first data structure. So let's wrap it up here, and I will see you soon.